the talk is titled Constrained Neural Networks for Thermal Vision. And without further ado, Massimiliano, you can go ahead and start.
Thank you. Good evening, everyone. My name is Massimiliano Galanti, and I'm a student. Actually, I just graduated at Politecnico di Milano, Artificial Intelligence and Robotic Lab, that is AIR Lab, Italy. And this work has been supervised by Danilo Pau from ST Microelectronics and Professor Matteo Matteucci of Politecnico di Milano. The problem here is to detect people in thermal camera frames. So specifically, we are dealing with humans in an outdoor environment in typical, you can think about typical border patrolling scenario in various weather conditions. So on a sunny day, for example, at night in mist or fog or raining condition. As you can see on the left, we are starting from annotated thermal images from a starting data set. And we started by removing all the artifacts from the image and tiling it. The resulting set of tiles then has been divided into human and not human classes and has been used to train the CNN you can see in the middle of the screen. A CNN that has been designed taking into account the specific constraint of an embedded environment. So trying to keep it as simple as possible. The performance of this CNN running on a TensorFlow Keras cloud node are summarized on the right. Above, you can see an example of the annotated result. The red circle is actually identifying human in the landscape. And below, you can see the confusion matrix, which expose a pretty diagonal form. Then, thanks to ST Microelectronics framework, it's called XCube-AI, the resulting Keras CNN has been ported into C code for the STM32 architecture, specifically an STM32F7, which is a kind of mid to high range microcontroller running at 200 megahertz, of course, with cache enabled. You see that from the beginning, latency is at almost 5 frames per second, which is acceptable, but the flash requirement shows that Keras structures take more than half of the available flash space on the microcontroller, leaving very few space for the actual application. So two distinct optimization approaches have been evaluated. The first one is the compression of the network, which is really available in the tool. That means just compressing the network representation to save space, particularly flash space. This can be applied with two different factors, factor by 4 and by 8. And no latency effect has been observed by this optimization. The second optimization instead is to apply post-training quantization to the Keras network, so to substitute the 32-bit floating types with the TF-lite 8-bit integers. This means obtaining a TF-lite representation that can be again imported into XCube-AI, translated into C code, and run with the help of the CubeAI proprietary runtime implementation. Unsurprisingly, the flash requirements are reduced by a factor of 4. That is the ratio between the two representations. RAM requirements benefit a bit by such approaches, but the most striking result is on the FPS. You can see that it more than doubled. Then on the conclusion, so can we implement a self-contained STM32 solution for the given problem? Yes, we can do that, and we can achieve a little bit more than 10 frames per second on a medium range STM32F7 running at 200 megahertz again. This means that we have plenty of FPS to detect actual human movement in the landscape. So what's next? We can implement a multi-frame strategy, for example, to mitigate false positives and false negatives, for example, by averaging the results of a sequence of frames, since it is extremely unlikely in the real scenario that the person is detected on a single isolated frame. Then, as another improvement, we can benchmark different STM32s to identify the best cost-performance trade-off. And then we can, of course, implement a prototype, continuously streaming the frames from a thermal camera to the actual device, indifferently via network connection or direct GPIO interfacing. And thank you for the session.
Thank you. There is one question here. What was the main reason of using Keras in the project instead of PyTorch or TensorFlow?
Oh, actually, the part of this work derived from another work. So it is itself an evolution of a previous work. So that kind of heritage was from the previous work. So this has been developed as an improvement on a previous work, which was evaluating on those bases.
Okay, thank you.
I want to thank our sponsors that made this event possible. So the premier sponsors, Newton, working on automated TinyML. If you were there a few days ago, they had a keynote explaining what they're doing. Executive sponsors are ARM, Edge Impulse as well, and Qualcomm, Sentient, and then our platinum sponsors, we have Infineon and Reality AI. Gold sponsors are Latent AI, SensiML, and our silver sponsors are EMEA, Greenwaves, HOTG, Imagimop, GISO, Seed, and ST. And with that, I thank you very much for staying on till the very last end, the last day of the last session of the last day. And with that, I think we can close the forum for this year. Thank you everybody for contributing. Thank you, Andreas, for also moderating this session.